Today we have lesson 10.2, where we're going to talk about congruent chords. The objective is that we will apply the relationship between congruent chords of a circle. So let's see what this means. First, I'd like you to take a second to work on this warm-up. This applies what we learned yesterday. So you're given circle O, and you've got BO is perpendicular to PQ. BC is 5 and PQ is 30. Find the radius of this circle. You have this problem on your worksheet, so work on that. Enter your answer, and then we'll resume. Okay, now that you have your answer, let's see if you got it right. First of all, we have circle O, and we know that BO is perpendicular to PQ. So let's go ahead and mark our figure. And we know that BC is 5, so down here we have a 5, and PQ is 30. So if we know that BO is perpendicular to PQ, we know already from our theorem we learned yesterday that that radius there is going to bisect the chord. So if the entire chord is 30, then I know each one of these pieces will be 15. So now I need to find the radius. Okay, so did you have difficulty with that one? This is a little bit tricky. So from what we have here, we're asked to find the radius. So I'm going to go ahead and draw the radius in there. And this is really what I'm looking for. If I know that this point from O to Q is my radius, I also have a radius from O to B. Okay, so if you know OB is X, but yet BC is 5, then you can label OC as X minus 5. And now you see, I'm going to change colors here. Let's see. You see here you have your right triangle just like we have in the past, but it's a little tricky here because we've got a quadratic going on. Or maybe not, actually. Alright, so using the Pythagorean theorem, we have x minus 5 squared plus 15 squared is equal to x squared. I'll put it over here because I'm running out of room. Okay, sorry, I'm just getting used to my program here. So now let's multiply this out. So we have x squared is equal to x squared minus 10 squared, 10x, oops, plus 25 plus 225. There we go. So x squared equals x squared minus 10x plus 250. If you notice here, if I subtract the x squared from both sides, it actually gets eliminated. So moving the 10x to the other side, I have 10x is equal to 250. So x is equal to 25. Okay, so how did you do? All right, moving on to the next slide. We're going to talk about the center chord relationships. Our theorem states that if two chords of a circle are equidistant from the center, then they are congruent. Okay, so what does this mean? If two chords are equidistant from the center, that means that from the point P to the chord, the distance there is going to be the same from P to X as it is from P to Y. And therefore I have my congruent marks there. Okay, so if those two chords are equidistant from the center, then what I'm saying is that this chord, let me change colors here again. All right, this chord is kind of hard to mark, is congruent to this chord. Okay, so let's try that out. If I'm given this circle P, and I know that PX is congruent to PY, and I'm given that AB is 12x minus 5, and CD is 4x plus 19, how would you solve this to find CD, the length of CD? Go ahead and try that, and then we'll come back and do it together. Okay, so since I know that the chords are going to be congruent because px is equal to py, then I'm going to set these two chords equal. So 12x minus 5 is equal to 4x plus 19. All right, so solving for x, I have 8x is equal to 24, so x is equal to 3. If x is equal to 3, then I'm going to plug that back in. 4 times 3 plus 19. And hopefully everybody got the same answer. That gives us 31. All right, let's move on to our next theorem. This is also a center chord relationship. Our theorem states that if two chords of a circle are congruent, then they are equidistant from the center of the circle. Does this look familiar? Okay, again, this is the converse. So now I'm saying that if these two chords are congruent, then I would know they're equidistant from the center. So then I would know that the distance from O to F would be the same as the distance from O to E. Okay, so let's try that out. If I'm given, in this example, circle O, and I know that AB is congruent to CD, and OE equals 6x plus 14, and OF is 4 minus 4x, find OE. So go ahead and calculate that, and we'll see how you did. Okay, so if OE is 6x plus 14 and OF is 4 minus 4x, I know that these two segments need to be congruent, so I'm going to set them equal. 6x plus 14 is equal to 4 minus 4x. Okay, solving for x, I get 10x is equal to negative 10. So x is equal to negative 1. If x is equal to negative 1 and I'm trying to find OE, I plug that in. And I get 8. How'd you do? Okay, let's move on. We're going to finish this up with a proof. Okay, in this proof I have triangle ABC is an isosceles triangle with the base AC. So what does that tell me? If the base is AC, then I know that AB is going to be congruent to BC. Kind of hard to show that. And I've got this circle P, so I know P is the center of my circle, and PQ is perpendicular to AB, and PQ is perpendicular to CB. You know, I think I have a typo there again. This should be PR is congruent. Oops, PR is congruent, or is perpendicular to CB. Sorry about that. Okay, and I have that marked in the picture already. So I'm going to start with my given. Okay, I thought I was recording, but something happened there. I think an alarm came up on my machine, so I'm not sure where I was. I'm going to start with the given, where I know that triangle ABC is isosceles with base AC, and I also have circle P, oops, that's circle P. PQ is perpendicular to AB, and PR, my mistake there, is perpendicular to CB. Okay, these are both given. Alright, I already kind of marked it on the picture or talked about it, but because I have this isosceles triangle, then I know that AB is congruent to BC. Okay? So the reasoning is because an isosceles triangle has two congruent sides. All right, next, what I want to say here is that PQ is congruent to PR. How do I know that? PQ is congruent to PR. Okay, think about what you would write as your reason there. Okay, I'm not sure how that worked, but I've already written in the reason. My reasoning is if two chords are congruent, then they are equidistant from the center. That's one of the theorems we talked about. Okay? And then the last thing I can say then, of course, is that triangle PQR is isosceles. And that's because a triangle with two congruent sides is isosceles. Now, a question for you. Why do you think it was necessary to be given PQ is perpendicular to AB and PR is perpendicular to CB, even though they did not seem to play an active role in this proof? Take a second to answer that question, and then we'll move on. Okay, nice job today. That's it for the lesson. Our homework is going to be in the book, page 447. In case you don't have your book, I know we're short on books, I have made a worksheet just copying out the problems from the book. So you can grab that worksheet from the Google Calendar under today's date. I'll see you later.